Who here, a year or two ago, thought that they'd be living through a global pandemic, a new virus that spread across the world and killed millions? One of the scariest things about this virus is that when it broke out, we had next to no cures or treatments to fight against COVID-19. But viruses, new and old, aren't our only worries. From infectious bacteria that have become immune to our antibiotics to increased rates of cancers, humanity is struggling to find solutions to our ever-evolving medical needs. To find our medicines of the future, we're turning to Mother Nature for help. My name's Sam Afalus, and I'm an underwater alchemist. But instead of turning lead to gold, I'm turning Ireland's hidden treasure, deep-sea coral reefs, into our medicines of the future. For thousands of years, we have turned to natural remedies made from the plants and animals that surround us to cure us of our ailments. Put your hand up if when you have a cold or a cough, you use natural treatments like honey or ginger to help relieve your symptoms. Hot whiskies? The reason why these natural remedies work is they rely on molecules called specialized metabolites that are mainly produced by organisms that can't move, like plants and mushrooms, to defend themselves from diseases and predators. Over the past 200 years, scientists have traveled to the four corners of our world in search of organisms that may contain these medicinal molecules. This fundamental research has resulted in over half our medicines today being derived and inspired by natural sources. Although these scientists scoured the surface of our planet for organisms with these potential medicines, there was one area that remained underexplored, and it just so happened to be the biggest part: the oceans. Our oceans cover over 3/4 of the Earth's surface and contain the most biodiverse ecosystems on our planet. In Ireland, we own 8 times more ocean than we do land, and it's filled with forms of life that seem alien to us. All of these creatures you see here, I photographed in Irish waters along the Connemara coastline, and you can discover them for yourselves if you visit rock pools or snorkel through the kelp forests. When Jacques Cousteau invented scuba diving in the 1940s, this provided scientists with the tools required to explore these diverse ecosystems. Now, they could spend hours underwater, uncovering hundreds of new species, from colorful corals to spectacular sponges of all shapes and sizes. When chemists got their hands on these samples and started analyzing the molecules that these animals made, they were amazed. New molecules, many of which chemists thought would be impossible to form. But then, Mother Nature had something to say. When they tested the potential of turning these new molecules into medicines, they found that many of these new molecules could kill the most potent of drug-resistant bacteria, destroy the most virulent of cancers, and even be used to treat pain. There are 17 medicines today in your local pharmacies and hospitals that are derived from marine sources. One of these medicines in particular, zirconitide, was isolated from the Conus magnus, also known as the magical cone snail. What's magic about this sea snail isn't just its beautiful shell and pattern, but one of the natural molecules it produces is such an effective painkiller that it's 1,000 times stronger than morphine. And you're probably asking yourself, why would a sea snail produce something that's 1,000 times stronger than morphine? Is that why they're slow? And the answer, ingenious evolution. See, these sea snails hunt fish, and they don't have the speed to chase down their prey like a lion hunts a gazelle. So instead, they harpoon their prey, injecting it with a potent mixture of neurotoxins, like zirconitide, that paralyze the fish instantly. It's zirconitide's ability to target the nervous system of vertebrates, like us, that makes it such an effective painkiller. And while scuba diving was a revolutionary leap forward, allowing scientists to study our coastal marine ecosystems, our oceans extend far past our shores to unimaginable depths. We can only dive so deep, before the physical pressure pressing down causes lethal effects. This left the vast majority of our oceans underexplored. More people have been to space than have been to our ocean's deepest depths. To find our medicines of the future, we went to explore these depths on the research vessel, the Celtic Explorer, and sailed south from Irish shores to some of the largest geographical features that scar our planet. Submarine canyon systems like Whittard Canyon, where the sea floor drops from 300 meters to 3,000 meters. And it's here, in some of the most extreme environmental conditions in the world, that deep-sea coral reefs flourish. Conditions at these depths are so extreme, we have to use a state-of-the-art robotic submarine the size of a minibus to collect our samples. And when I say extreme conditions, I really mean extreme. Unlike the coral reefs that the cone snails inhabit, instead of the water being warm and tropical, it's the same temperature as your fridge. Instead of it being bright, clear, and sunny, it's pitch black and has never seen the light of day, permanently bathed in eternal darkness. And instead of being able to swim around freely, if you were to dive to these depths, you would be crushed in seconds with the sheer pressure, equating to the weight of 20 elephants standing on your head. Even with these harsh conditions, deep-sea coral reefs are among the most biodiverse ecosystems in the world, rivaling that of the Great Barrier Reef and the Amazonian rainforest. In this one picture alone, there are hundreds of unique species, from starfish to sea fans, cup corals to crinoids, all of which have adapted over millions of years to thrive in this unforgiving environment. Many of these animals are new to science and remain in the final frontier in studying life on our planet. Some of these animals are so alien, like deep-sea jellyfish, that they even inspired the creatures in James Cameron's Avatar after the director explored the deep sea. This abundance of biodiversity creates competition, especially between the filter-feeding animals, to fight for space to grow as far out into the water current as possible, to catch as much food as possible. For millions of years, this battle for space and food has raged on in the darkness, resulting in some of the most beautiful biological creations our world is yet to see. And this is an example of some of that beauty. A 2-meter wide trumpet sponge we found at a depth of 1.5 kilometers. This species of sponge has evolved to grow an intricate skeleton of interwoven glass fibers that stretch out into the current. But this beauty comes with the dark side. It turns out the battle for these sponges and corals to survive and thrive is a battle that relies on chemical warfare. My aim is to isolate these chemical weapons, which we can then utilize in our own fights against microbes and cancers. If you look closely at this sponge, there are these tiny yellow dots. Each of those yellow dots is a coral-like animal growing on the sponge, using it as a scaffold to feed in the current. This can negatively affect the sponge, so in a response, the sponge and its microbiome produce toxic compounds to kill the corals. And in a response to that, the corals produce their own toxic compounds to kill the sponge. It's these compounds we aim to develop into new anti-cancer therapies and future antibiotics. But these reefs contain thousands of species, and each species may contain thousands of molecules. So you might imagine that finding the one that could be a cure for a type of cancer or might stop the next pandemic would be like the proverbial finding a needle in a haystack in the dark. But the same way that we soak berries and spices in alcohol to make gin, we soak our corals and sponges in alcohol to make coral and sponge gin, which we call extract. We then feed this extract to different diseases, cancers, malaria, viruses, even brain-eating amoebas, and we wait. Most of the time, nothing happens. But every once in a while, one of these extracts manages to kill a disease, letting us know it contains a natural molecule with the potential to be turned into a medicine. We then isolate these molecules and test them against the disease again until we find the one molecule that has resulted from millions of years of evolution in our ocean's dark depths that we can now use in our own wars against cancers, bacteria, and viruses. But once we find these medicines, we can't just rip these animals from the reef as our source. That would destroy the very vital biodiversity and resulting competition that created these molecules in the first place. We don't need to come up with a complex mechanism for manufacturing them in a lab. Some of these molecules are so complex, we couldn't even if we tried. But Mother Nature has done the hard work for us. Hidden in the DNA of these animals and their associated microbes are the genes which carry the biological recipes for producing these molecules. Using cutting-edge techniques, we can take these genes and insert them into microbes like yeast, allowing us to grow them in a bioreactor, getting the microbes to do the hard work for us, producing our medicines in a sustainable, cost-effective way without the need for harsh chemicals, such as heavy metals, that can be required in more traditional manufacturing processes. Our research isn't just to help protect the health of humanity, but also to protect the health of these hidden reefs. Deep-sea reefs wrap around our entire planet, and already, over half the reefs that exist have been destroyed, turned to lifeless rubble by trawling and longline fishing. With new threats on the horizon, like deep-sea mining, they're in more danger now than ever before. By proving that their unique biodiversity can be a natural resource for providing us with new medicines, not only does this give a public health incentive to protect these reefs, but a financial one also. Like how safari tours provide the economic incentive to conserve savanna ecosystems, potential profits from pharmaceutical sales could provide the financial sustainability to explore and protect these reefs. We need new medicines today more than ever before, and the incredible biodiversity that deep-sea reefs offer have created a fantastic library of natural molecules which we can develop into our future medicines. Already, our research group has found potential medicines against asthma, malaria, and even COVID-19, showing the unbelievable potential of these reefs. To protect our own health, we need to protect the health of deep-sea coral reefs. Our future pharmacies are hidden in our seas. Thank you.